All right, what's up, everybody? So, this presentation is to introduce you to our first statistical test for inferential statistics, rather. Not, I mean, we've done some central tendency up until now, but now we're focused on some inferential statistics, and the t-test is our first one. So as far as knowledge building and what this module, this presentation is going to introduce you to, so we're building on the hypothesis testing steps 1, 2, and 4. From our previous presentation on hypothesis testing, remember that step 3 is about data collection and analysis of your sample. As it relates to what we're going to be addressing here in this presentation, we're not going to concern ourselves at this moment with data collection, so we're primarily focused on steps 1, 2, and 4. That's more specifically focused on null and research hypotheses, a little bit more context of introducing the alpha level into this, and then finally making a decision. We'll also be learning about t-ratios and t-distributions and the relevance of these ideas to the t-test, and finally a little bit more about type 1 and type 2 errors. So just starting at the beginning, right, with hypotheses. So we learned that step 1 of hypothesis testing is to identify your null and research hypotheses. Each of them represent potential outcomes. When writing the null and research hypotheses for a study, we're going to primarily lean on the following method of writing our hypotheses. The first one is H0. Remember, that's your null hypothesis. I also want to encourage you, if you've got notes from your hypothesis testing module, this is where they're going to come into play. Remember that the null hypothesis is the idea that there's not going to be a significant difference between your sample and your population. And we'll see how that lends itself to each of the t-tests we're going to learn about. But broadly speaking, we're essentially trying to say that the hypothesized population mean that we are, trying to assess is effectively the same as the true population mean. And when those two means are the same, then there's no difference between the information we've gathered and this other data that we're comparing it against. And so that's why we would write mu equals mu. So population mean equals population mean. Remember that for your research hypothesis, as opposed to the null hypothesis in this particular class, I also want to just kind of throw in here as a brief reminder that when it comes to your research hypotheses, it is possible to have more than one research hypothesis. For this class, we're only focused on the null and research hypothesis. And we're not going to break down our research hypothesis into different types of outcomes. We're only focused on whether in the null hypothesis there's not a significant difference, or in the research hypothesis if there is a significant difference. And so that is to say that if we find a difference between the hypothesized population mean and the mean of the sample that we've collected and its relationship to the population, then if those two are not the same, population mean to hypothesized population mean, then we are finding a significant difference, right? That's our research hypothesis. So while these two examples that I provided here are how you write them generally speaking, we're going to see the appropriate formatting for each test as we learn them. And so throughout this presentation, remember that this is focused on the t-test. Throughout the rest of the semester, we're going to learn about other statistical tests that we can conduct. But for the t-test and each different type of t-test we're going to be introduced to, you'll see what the appropriate formatting for creating your null and research hypotheses for those are. So what is a t-test? A t-test is a statistical analysis that compares means to determine if there's a significant difference. There are 3 types of t-tests that we're going to learn about. The first is a one-sample t-test. The second is an independent samples t-test, sometimes referred to as a two-sample t-test. And finally, we have the dependent samples t-test, which can be referred to as before-after, it could be referred to as paired, or it could be referred to as repeated measures. I incorporate these alternative terms to use for these tests because if you're reading through research and you're seeing these different terms, a particular researcher may preference using before after or using paired t-test instead of using dependent samples. So getting familiar with the language is an important aspect of learning statistics as a whole. Okay. For each t-test, we're going to calculate a t-ratio, degrees of freedom, identify the critical t-ratio, and compare our calculated t-ratio to the critical t-ratio. T-tests effectively compare means, and so that means therefore that the dependent variable of our hypothesis must be an interval ratio variable that we can calculate a mean for. Remember that it is not possible to calculate a mean for any kind of variable. We cannot calculate a mean if we're collecting data on race, right? We can't add different racial groups together, divide them by however many there are, and come to some sort of conclusion, right? For some ordinal variables, we also can't calculate an average for them. We can't, add different educational levels. So being a freshman, we can't add that to being a junior, divide by two, and get something, right? So whatever our dependent variable is, it has to be something that we can calculate a mean for. I also want to include here that for this previous bullet point about calculating t-ratio, degrees of freedom, identifying critical t-ratio, in this presentation, I'm going to introduce you to those steps because it's important for you to understand what those steps are. But what I want to emphasize here is that when it comes to your learning checks and when it comes to the exams, I'm not actually going to test you on the hand calculations. I want you to know what they are so that you have an understanding of what's going on in the background. But the real piece that I want you to draw from this is what the purpose of each of these tests are, how we use them, and finally, when we are conducting these tests in SPSS, how do we interpret the results and what it means for our research question. So again, I want to emphasize, I'm showing you the steps required to calculate these things by hand, but we are not going, or you're not expected to hand calculate any t-tests or really any of the tests from here on out on any learning checks or exams. All right. Okay, so just coming back to this point about dependent variables, I actually, just kind of gave it away a little bit as I was describing what we can and can't calculate average or means for. And so as an example of a research scenario, if we want to know if there's a significant difference between the GPAs for Black students versus Asian students, our independent variable, our IV, is going to be race. That's the variable that we are able to categorize or group some of our participants together, and our dependent variable dv is going to be GPA. We can calculate a GPA mean. We can collect a bunch of different GPAs from students, add those all together, divide by however many there are, and determine what an average GPA is. And so in that case, our independent variable is something that, our dependent variable is something that we can calculate a mean for, which is a necessary component of conducting a t-test.